Equilibrium problem. And in this one, we're given the equilibrium constant, and we're given initial concentrations, and we're asked, once reaction is over, what are the equilibrium concentrations of all species, okay? Now, if I look up here, I have CO plus Cl2 forming CoCl2, and we're given 1 mole of CoCl2 in a 10-liter vessel. So its concentration is 0.1 molar. And we're not given any CO or Cl2. So we must be making those. So I'm going to write the equation backwards and say that CoCl2 is really my reactant, and it's going to make CO plus Cl2. And the K for this equation is the reciprocal for the K up on the overlay. So it's 1 over 26.7. Okay? Any questions? Now, what we're having here is our Rice diagram. And so this was my reaction. I have my initial conditions, the change, and then I'm going to have my equilibria conditions, and this is what I'm trying to solve. How much of the CoCl2 is left after reaction, how much of this is made, and how much of this is made. So I have the initial concentration of this is 0.1 molar. That is 1 mole into 10 liters. Okay, I have none of this, and I have none of this. Now, the coefficients are all 1, so for every one of these that I consume, I make one of these, and I make one of these. So at equilibrium, I have 0.1 minus x of this. I have x of this and x of this. Okay? Now, I can now relate this to my equilibrium constant. K is equal to CO at equilibria, Cl2 at equilibria, over CoCl2, and the K is equal to 1 over 26.7, which is equal to x times x, so I'm going to call that x squared, over 0.1 minus x. Okay? Now, I have this equation here, and I need to bring this up to a common factor. So if I bring this up here and here, I have a quadratic equation. So I have 0.1 minus x equals x squared times 26.7. So this comes up to the form of 26.7 x squared plus x minus 0.1 equals 0. And we know that this is of the form ax squared. Put the x down here. Ax squared plus bx plus c equals 0. And you know that we can use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we substitute that in, we get x is equal to negative 1 plus or minus the square root of 1 squared, negative b, 1 squared, minus 4 times 26.7 times a minus 0.1, divide by 2 times 26.7. And we have two solutions because of the square root. We have 0.045 or minus 0.082. Okay? Now, if I look here, excuse me, this is a minus 0.082. If this was the solution, then I'd have a negative concentration at equilibria, which is nonsense, okay? And I would have had more than I started with of this, which is nonsense. So this is the logical solution. And so at equilibria, my CoCl2 is 0.1 minus 0.045 0.1 minus x, which is 0.055, and the CO equals the Cl2, which equals x, which equals 0.045 molar, and that's molar. Okay? Now, one comment, okay? If this was a 0 and these had values, and I had written this the way up on the overlay, then what I'm calling my reactant is really a product, okay? So in that case, the proper value of x would have been the negative. So if you solve it up there using 26.7 and say CO plus Cl2 forms COCl2, the negative value would have been the one that made sense, okay? Because what you were calling a reactant was really a product, okay? And I'll probably solve that in another video so you can compare this solution to that solution, but try it yourself too, okay? Good luck, and I hope this helps.